This video is about extraction of aluminium from its bauxite ore. It is from chemistry code 5070. As we know that aluminium is high up in the reactivity series, so it cannot be extracted by reduction with carbon just like iron. So we need to do electrolysis for extraction of aluminium from its ore bauxite. And for this purpose we are taking a container which is made up of steel and internally lined with graphite and have a graphite rods in it which are acting as electrode. The lining and rods are used made up of graphite because graphite is a very good conductor of electricity, as we have studied in the molecular covalent compounds chapter, where we studied that carbon has two allotropic forms, diamond and graphite. Graphite is a very high melting point and is a very good conductor of electricity. Because of these two qualities, graphite is used as electrode in the extraction of aluminium by electrolysis. And the bauxite ore is used for this extraction, and the ore must be in the molten or in the dissolved form so that the ions are free to conduct electricity. The electrodes, two electrodes which are made up of graphite is the one which is internally lined with the steel case, is connected to the negative terminal of the battery and is called as cathode, and those rods of graphite which we are hanging in the electrolytic solution are also made up of graphite, and they are connected to the positive terminal of the battery and they form the anode. Now, in order to dissolve and melt the aluminium oxide, which is a bauxite ore of aluminium, is either dissolved in cryolite and or either melted. But the melting point of bauxite ore is very high, around 2000 degrees centigrade, so it is going to consume very much high fuel, so making the reaction very expensive. So to save on the fuel, we would like to dissolve bauxite into cryolite, because we know from our previous information that the impurities decreases the melting point. So what we do is we are dissolving bauxite ore into cryolite to reduce its melting point. That will save a lot of fuel, and when we'll dissolve it, its melting point will decrease, of course. So the purpose of cryolite is to dissolve bauxite ore and to reduce its melting point. So this information is very important from past paper point of view, because they are going to ask you question which we will be doing at the end of this video, and you will know that how many marks question are expected from this topic. So this information you need to memorize, that why cryolite is used in this process of extraction of aluminium from its ore bauxite. Okay, this is the important information, the structure of apparatus and the charges on the electrode, the name of the electrode, and the construction, how it is made up of, and why cryolite is used, and which ore of aluminium is used as used for the extraction of aluminium. So let's have a summary of it. The apparatus is made up of steel case internally lined with the graphite, which is connected to the negative terminal of the battery and act as cathode, whereas the rods made up of graphite are hanging in the electrolytic solution and they are connected to the positive terminal of the battery and act as anode. Now let's discuss that how this process occurs, what half cell reactions are occurring, and where is the transfer of electron, how it occurs. So first of all, we see that at cathode reduction occurs. You can memorize it with the mnemonic red cat, because red stands for reduction and cat stands for cathodes. In reduction, there is a addition of electrons, so aluminium, as it is positively charged ion, and cathode, it is negatively charged electrode, so aluminium ions are get attracted to cathode, and there it is going to take up electrons. These electrons are added to aluminium ion. As you can see, In the equation, aluminium plus 3 is gaining 3 electron and converting to aluminium metal. Aluminium is collected at the bottom of the steel container, and there is an opening from where we can extract aluminium in the molten state. The half cell equation is written on the screen. You can see how we will write reduction reaction occurring at cathode. Aluminium plus 3, which is a cation, is going to take up electrons from cathode, because at cathode is rich of electron as it is negatively charged. So electrons are taken up by aluminium ion at cathode and converting into aluminium metal. In the molten state, it settles at the bottom and taken out or collected from the opening which is present at the bottom of the steel tank. The second half cell reaction is the oxidation, which is occurring at anode. N-ox is the mnemonic to memorize this. N stands for anode and ox stands for oxidation. So that means oxidation occurs at anode. Oxidation is a loss of electrons. So oxide ions, which are negatively charged, are attracted to the positively charged electrode, which is anode. There they are losing their excess of electron, as oxide ions are negatively charged. That means they are rich in electron. So they are losing their electron at anode and undergo oxidation, means they oxidize and become oxygen gas, and electrons are being lost in this case, which are through the wire they are traveling to cathode. And at cathode, of course, we already know that aluminium ions are present to take up the electrons. So this is how this occurs. The half cell reaction you can see is on the screen. At anode, an oxidation reaction occurs where oxide ions, which are negatively charged ions, are giving up electron. One oxide ion gives off 2 electrons. So if 2 ions are present in the equation as it is shown, so it is going to lose, of course, 4 electrons and oxygen molecule is formed. Why we have written 2 oxide ions? Why not 1? Because we know that oxygen is a diatomic gas. So we have to write 2 oxide ions. That's how it makes oxygen gas molecule, and 4 electrons are lost in this case. So adding up the two half cell reactions, the one is at cathode, the other is at anode. If we write the overall equation, we see that aluminium oxide is electrolyzing, giving us aluminium metal in the liquid state and oxygen gas. And the purpose of doing this process was to extract molten aluminium, which we have finally done. Now let's see what else occurs during the reaction in the container, and why we need to replace the anode rods, which are made up of graphite, further if we want to continue the reaction. It is because the anode rods, which are made up of graphite, is actually carbon, and carbon has a great tendency to react with oxygen at a high temperature. So these carbon rods are going to react with the molecular oxygen, which is being formed due to the electrolytic as a result of electrolytic reaction at anode. So carbon dioxide gas is formed. These carbon rods are being dissolved. So in order to continue the reaction, we have to replace the rods which are made up of carbon at anode. Now let's try some past paper questions which you can expect from this topic. The first question says that the modern method of extracting aluminium is the electrolysis of molten electrolyte aluminium oxide dissolved in cryolite. Now the equation is given. Both the electrodes are made up of carbon. Give 2 reasons why the oxide is dissolved in cryolite. As I have already shared the information in the video while I was explaining this topic, that what is the reason behind the using cryolite. So you need to think for a minute and then share the answer and see if you are right or wrong. The first mark, if you have written the answer that reduce the melting point of aluminium oxide, the first marks you have scored. That is correct. And if you have written that allow aluminium oxide to conduct electricity, or even if you have written that so that aluminium oxide is dissolved in cryolite so it conduct electricity, is the correct answer. So you score 2 marks in that case. The second part says complete the ionic half equation for the reaction at the anode. So at anode, oxidation occurs. Oxidation is a loss of electrons. So the equation where oxide ions are losing electron is the correct equation for this reaction. And the last part of this question says that why do the carbon anode need to be replaced frequently? Okay, this was explained in the last part of the video, that why we need to replace carbon anode And you know the reason is because oxygen is being formed at anode, and oxygen and carbon has a great tendency to react at a high temperature, so carbon dioxide gas is formed. So what are you going to write? You will write the react to form carbon dioxide. So you are going to score 1 mark for this, and you can add the equation as well. Carbon plus oxygen, carbon solid because electrode rods are solid anyways, and oxygen gas which is formed there react together at a high temperature to form carbon dioxide gas. So that dissolves carbon rods. They need to be replaced because if we need to continue the reaction without anode, the reaction cannot continue, so we need to replace it. This was an explanation, but the only sentence you are going to write is they react to form carbon dioxide gas along with the equation to support your answer. Okay, this was all about the extraction of aluminium from bauxite ore. So this was the end of the video. In the next video, I will be solving the questions, past paper questions, paper 1 of this topic. I'm putting the link of that video of past papers, paper 1 question in the description of this video, so it is easier for you to find it. I'll see you in the next video. Thank you. God bless you. Allah Hafiz.